the 3 projections. This is our stage 1 initial position. If you remember these stages, stage 1 would be always initial position, stage 2 would be always be implementing horizontal plane angle, and stage 3 incorporating VP angle to the HP angle and final object. Now we will proceed further to the stage 2. This is our stage 1. Now we will proceed further to the stage 2. For this I have marked a random point. Now it has been clearly stated that angle with HP is 45 degrees. I am drawing a line, a reference line, rather say 45 degrees, a reference line. I have drawn a reference line over here, taking A dash to D dash as radius, marking an arc. So we have got A double dash, B double dash, D double dash and E double dash. Now we need to trace this C and F. So A to C dash, A dash to C dash, mark another arc. We have got C double dash, F double dash, traced at 45 degrees. I have done nothing, I have just rotated that line at 45 degrees. Now we need to take vertical projections of it towards the downside. We have taken the vertical projections, will match with the horizontal one. Join the respective points. As you can see, A line to A line, B line to B line, F double dash to F, C double dash to C, D double dash to D, and E double dash to E. We have got stage 2, where this 25 mm side hexagonal plate, if it is rotated to 45 degrees to the HP, how it looked like, it's been shown in the stage 2. It will look like this, giving the same names. If this hexagonal plane has been rotated or been putted at 45 degrees with the HP, then it will look like this. But that's not the end of the problem. We need to incorporate VP angle, that is 30 degrees, to this HP. Means that this stage 1 problem is 45 degrees inclined to HP and 30 degrees inclined to VP. We need to take the final. For that we will proceed further to the stage 3. We will proceed further to the stage 3. I am marking a random point on the XY line. Now marking a reference line at 30 degrees, marking a reference line at 30 degrees. Now I need to take the replica of this hexagon over here. I need the replica of this hexagon over here. Like I have just turned this hexagon like 30 degrees to VP. So what I need to do, I have got point A. I am just putting point A anywhere. With reference to this, I will put another point, A to B. AB. We have find the side AB. Now, with reference to this AB side, we can find out another side as well. Now, as you can see that this A and E are perpendicularly equally distanced. So, I am just putting perpendicular line from both A and B, extending as a reference like this. I have got the distance of A to E. Mark. B to D. Mark. What I have received is point number D and E. This is point number E and this is point number D. Now only remaining 2 points are there, C and F. We have got the distance of A to F and E to F. We have got the distance of B to C and C to D. Intersecting arc shows the C and F point. This portion is point number C and this is point number F. I have taken the replica of this stage 2 over here. I have just rotated it 30 degrees. Now I will take vertical projections from it. Exactly, projections to be vertical only. Like this, I have taken the projections matching with the horizontal one. Only 2 projections. Mark the point very carefully with the portions itself. C would be intersect with the C only. F would be intersect with the F only. A and B would be intersecting with A and B only. D intersect with D double dash. E intersect with the E double dash. We have got the 6 points. By joining that point, those points, we have received our final object. A triple dash, B triple dash, C triple dash, D triple dash, E triple dash and F triple dash. As you can clearly see that it has been said that a side is resting on the HP. We have seen in the projections of a line and projections of point that if anything is on HP or VP, that lies on the XY line. You can clearly see that AB line has been on the XY line, which means that AB line is resting on the HP. Now this clearly shows that this hexagonal plane is 45 degrees inclined to HP and 30 degrees inclined to VP. So this is how you can draw projections of a plane problem. Starting again stage 1. Stage 1 shows that 25 mm side of hexagonal plane is there. So in this starting we have just drawn a hexagonal plane of 25 mm side each. If you can see that the inside angle would be 120 degrees. By taking 120 degrees angle, you can easily draw hexagonal plane. Now taking vertical projections, I have given the nomenclature A to F. So I have taken the projection A dash B dash together, C dash F dash together, and D dash E dash together. Now after completion of the initial stage 1, stage 2 comes to place. In stage 2, we will incorporate HP angle to the starting position. Now HP angle is given as 45 degrees. So what I have done is, at random point I have taken a mark a point with use of the protractor. I have drawn a reference line of 45 degrees. Over here from the starting position A dash to D dash, I have taken A dash to D dash on the reference line, cut it out, drawing a full line. Now A dash to C dash, so I have done the replica at 45 degrees. Now I have transferred the vertical projections matching with the stage 1 horizontal projections, and I have received a stage 2 hexagonal plane look. That hexagonal plane will how look like at 45 degrees to HP angle. Now I have taken the replica of the same stage 2 over here in stage 3. In stage 3 we have incorporated VP angle, that is VP angle is 30 degrees. So we have incorporated 30 degrees to this. We have taken the vertical projections matching with this horizontal projections, and we have got the our final object. So this is how we can draw projections of a plane. Always remember that this process will always be 3-stage process only. Remember, stage by stage only. Our next problem, we need to draw involute of a pentagon of 25 mm side. Now when we talk about a involute, what is the meaning of involute? Involute is something, the curve when any polygon converted into the string and then which curve traced is called involute. Now over here we have got the pentagon of 25 mm side. So if we convert a pentagon of 25 mm side in involute, then what would be the string length? String length would be number of side, that is 5, and length of the side, that is 25, which means that the string length would be 125 mm. And while converting it to the string, we will see that what is the involute traced. Now let's have a look at the how we can trace the involute. First of all, we will draw a pentagon. You can draw pentagon using either 3-circle method, or you can draw pentagon using the angles. I am using with the 3-circle method over here. Drawing a line of 25 mm in the 3-circle method. Let's call it AB. Let's call it AB. A as center, AB as radius. Draw a circle. On another side, B as center, AB as radius. Draw a circle. The name of method is 3-circle method. So the third circle is missing. Now we have got the bisector by default. we have got the bisector by default. Now from the lower portion, let's call it O. From the lower portion, O to B as radius, and draw third circle. O to B as circle and third circle, where this intersect with the bisector is called O dash, and over here P, over here Q. Now extend that line P to O dash, extend till end. Q to O dash, extend to the end. Join A with this line, join B with this point. You have got point C. Now only two sides are remaining. Take AB as radius and C as center, marking and point. We have got our five-sided involute. We have got pentagon. This is D and this is E. Now we need to extend. This is our pentagon completed. Now we need to extend to draw the pentagon. Each side take A to B as radius and mark a continuous arc. I'll show you by highlighting it. Marking a continuous arc, naming as P1, taking E as center,